हेलो बच्चों, टुडे we will prove Gauss law. Now I am speaking loudly. See, uh, first of all, for clear understanding, you need one point here. See, this is area. Okay, this is plane. Okay, area is vector quantity because area made from length and breadth. Okay, so area is vector quantity. Okay, with respect to this point, direction of area in this directions are away from P. Okay, now please see here. With respect to this point, plane perpendicular. Okay, and with respect to this point, plane perpendicular, and with respect to this point, the direction of area radially outward or radially inward. Okay, now please see here. We are discussing now Gauss law. See, this is closed surface. This closed surface is called Gaussian surface. Okay, now please see, this area is tilted in this directions. This is direction of area. So what is the plane? Plane is here. This is called plane and this is called direction of area or plane. Okay, now please see, this area has two components. Along the electric field intensity or along the force. Along the force, how much? dA cos theta, or perpendicular to the force, dA sin theta. Okay, now please see, dA with respect to dA cos theta, lines penetrate. Okay, qualitatively this is called flux. Okay, with respect to dA cos theta, lines penetrate, and with respect to dA sin theta, no lines, electric field or electric lines penetrate. Okay, so one term is defined, that is called electric flux. Okay, means electric flux, loosely I am saying electric flux means what? Something pass through area, something penetrate through area, that is called flux. Now please see here. Here is charge. Suppose point charge is kept, Q inside, electrical charge, which is kept inside this kind of surface, closed surface. Okay, now please see, or called Gaussian surface. Now genius, please see, this dA cos theta, plane of dA cos theta, perpendicular to the radius, very small area, or in other words, plane area vector of dA cos theta along the radius, okay, outward of the radius, outwardly along the radius. Okay, please see. Now Gauss law suggests what? The flux through the closed surface. Flux means what, bacho? Something cross through the surface. The flux through the closed surface equals to charge inside by epsilon naught. Okay, dear? Okay, young mind, please see. Suppose through this surface, flux is d phi, right, bacho? Please. So, bacho, this is flux. Numerically, flux is nothing but product of electric field intensity, okay, perpendicular to this plane. So here I am writing dA cos theta. Okay, loosely, qualitatively you could say what? Something cross through area, that is called flux. Okay, bacho? Now please see this equation. Okay, now I want total flux, this closed surface. Okay, so you need what? You need integration. So total flux, becomes phi, है ना. Suppose the product of electric field, है ना, perpendicular to the plane, okay, area, है ना, is called flux. Please or please keep the concept of flux aside, है ना. First clear the concept of Gauss law. So could you write please the enclosed at the place of E? Please put here 1 by 4 pi epsilon naught q by r square, q inside dA cos theta. Now could you write please flux q inside by 4 pi epsilon naught r square, 4 pi epsilon naught 1. This one. Okay, now please see with respect to this point, dA cos theta perpendicular to the radius. If you take a small area, projection of a small area perpendicular to their radii, then you will get the ratio of area divided by r square. You will get a very important thing, है ना. This is very conceptual. You will get this whole value comes 4 pi. So please phi comes what? So phi comes seniors q inside by 4 pi epsilon naught. This whole come what? 4 pi. So when you solve, you will get phi comes q inside by epsilon naught. Okay. Now please see here. This one is closed surface, okay, who encloses no charge, suppose. Now outside of this closed surface, charge is kept, point charge is kept, whose value q out, right. Now please see, this area has two components along the electric field of magnitude dA cos theta and perpendicular to the electric field in this direction area dA sin theta. Now please tell, who contributes flux? Of course, in this direction lines pass, okay, in this direction no lines pass, right. So flux is the scalar quantity. Qualitatively it says what? Qualitatively it says the penetration of lines across this area, right. Please see here. Now, so what is the flux through this surface? So what is the flux? Please see here. d phi, you know, force intensity into, loosely I am saying, how much means, please see, along the direction of electric field, what is the area you should consider. So take the intensity and multiply it by dA cos theta. Now please integrate. If you integrate, so suppose left side comes phi, total flux. The total flux comes what? This one. So what is the total flux throughout the closed surface? So please integrate it. You know Coulomb's law? This is R. You know dA cos theta perpendicular to the radius. Okay? Please. You know the concept. So put here by Coulomb's law 1 by 4 pi epsilon naught q outside divided by r square into dA cos theta. Okay, young mind. Now please see here. Take constant outside the integration. So you will get what? Q out 4 pi epsilon naught dA cos theta by r square. You know the very first class of Gauss law. What we discussed in earlier class, okay, I said you the integration of dA cos theta by r square. Please remember, dA cos theta perpendicular to the radius. This value comes what? This value comes 0. Okay, so total associated flux becomes 0. Okay, please see, bachcho, qualitatively, what you say, this one is charged now. Okay, see, qualitatively, this is closed surface, or here is you keep charge outside. So please see by this example, whatever lines entered into the closed surface, same number of lines leave the same closed surface. Means whatever entering, same leaving. This is for qualitative study, है ना? But your concept belong to here. Okay, right? Please, है ना? You know, dear बच्चों, Gauss law is very important topic. Okay, please.